Valency, the most basic concept in chemistry without which we can't learn anything further in chemistry is valency. Okay, before that we need to understand some concepts like what is the structure of an atom. So atom is made up of three subatomic particles. So you can see here positively charged proton, the neutron which has no charge, and negatively charged electron. Proton and neutron, they will together form the nucleus of an atom, and you can see these circles are known as orbits or shell, and whichever is the last shell we call it as valence shell, or you can also call it as outermost shell. Before we go to valency concept, believe me, this you have to understand first why noble or inert gases are stable. So there are six inert gases. We know helium, neon, argon, krypton, xenon, radon. It forms the group 18 elements. So when you check the valence electrons of these elements, you will find that helium has 2 electrons and remaining 5 have 8 electrons. Now, why these are stable? Because their valence shell is complete and hence they have stable electronic configuration. Means we call it as a duplet rule for helium because it has 2 electrons. Duplet means 2. Octet rule means 8 electrons in the outermost shell. So means when the valence shell is complete, we say that that particular atom is stable. Okay. Now the question comes, how do other atoms achieve stability? Right? That is the biggest question. Let's understand that. By playing with valence electrons. Means when you take atom of an element other than noble or inert gases, they have three ways to become stable. That is by losing electron or by gaining electron, or they can share electrons with each other. So how do you define valency now is the number of valence electrons, or simply you can say the number of electrons that an atom can lose, gain or share during a chemical reaction is called valency. You might have come across different definition also, the combining capacity of an atom, but believe me, this is the most modern definition of valency. So how do other atoms become stable? By sharing, losing or gaining electron. They achieve the electronic configuration of nearest noble gases and hence they become stable. Means either they will have duplet in their valence shell or octet, means 8 electrons in their valence shell. Which elements lose electrons? Now the question comes, whether all the elements lose electrons? No. So the elements with 1, 2 or 3 electrons in valence shell lose their electron or electrons to attain stability. So for example, you take sodium. Sodium has one valence electron, it will lose that and become Na+. Because it is losing one electron, we say that its valence is 1 and it is monovalent. Mono means 1. Magnesium has 2 electrons, it will lose 2 electrons and become Mg+2, so valency is 2. So divalent, di means 2. Similarly, aluminium loses 3 electrons and become Al+3, so its valency is 3, so it is trivalent. And when they lose electrons, we know all of these will form cations. Cations means positively charged ions. So which lose electrons? You can see sodium, magnesium, aluminium, all of them are metals. And you can see electron configuration for ions 282828 means it has the electronic configuration of nearest noble gas, that is neon. Hence these ions are stable. Similarly, which elements gain electrons? So the elements with 5, 6 or 7 electrons in valence shell, so they gain electrons to attain stability. You can see chlorine, oxygen, nitrogen, so all of them are non-metals. So non-metals gain electrons. And chlorine has 7 electrons, it needs 1 electron to become stable to get an octet. So it will gain 1 electron and become chloride anion. Because it is gaining 1 electron, so its valency is 1, so it is again monovalent. Oxygen gains 2 electrons and becomes stable, so it's divalent. Nitrogen gains 3 electrons and becomes stable, it is trivalent. When the atoms gain electron, they form negatively charged ions. We call them as anions. Then examples of sharing electrons, right? Some gain, some lose, which can share electrons. Again, they will be nonmetals. The nonmetals mutually share electrons to attain stability. So how many electrons they are sharing, based on that we can predict their valency. For example, here HCl, hydrogen chloride. In this, valency of chlorine is 1 because it is forming one bond with hydrogen. In H2O, valency of oxygen is 2 because it is forming two bonds with hydrogen, means it is sharing two electrons. In ammonia, nitrogen is sharing 1, 2, 3 electrons, so its valency is 3. Or you can simply count the number of bonds it is forming, so that will give you the valency. Similarly, in methane, carbon is forming 4 bonds, 1, 2, 3, 4, so its valency is 4. In all of these compounds, molecules, the valency of hydrogen is 1. Okay, sir, but how to remember the valency of first 20 elements? So I'm going to give you two tricks. Trick number one, first you can make a mini periodic table of first 20 elements. Obviously, you have to remember them. I think you already know that. So then what you have to do when you write it in this way, write on the top of it number of valence electrons. Simply 1, 2, 3, 4, 5, 6, 7, 8. So the columns you can say, which you call as groups. So these will represent the number of valence electrons. Then at the bottom, you will write the valency of all the elements. Means whichever elements are coming in the same group, they have the same valency. You need not remember for all the elements. Just remember whatever for this particular group. Say here, for first group, the valency is 1, second group valency 2, third group valency 3, and fourth group valency 4. Observe here, from 1 to 4, the valency is increasing. It increases. But once it reaches 4, again from nitrogen to noble gases, phosphorus to noble gases, 5, 6, 7, 8, it is decreasing 3 to 1, 0. Okay, so how do you remember this? For initially it increases till the fourth group, then it will keep on decreasing. Or you can just 8 minus the number of valence electrons you can do only for these 5, 6, 7, 8 groups. Okay, so then 8 minus 5 is 3, 8 minus 6 is 2, 8 minus 7 is 1, 8 minus 8 is 0. Now the question comes, why noble gases valency is 0? Because we know that they are already stable. They do not lose, gain or share electrons with any other elements. This is the trick number 1. Trick number 2 to remember valency. First, what you have to do, write them in the list form. Okay, like this. First 20 elements in order. Then for all the noble gases, you write valency 0. Then start with hydrogen 1. Once whenever you come to 0, again start with 1. So 1, 2, 3. Then carbon will get 4. But once it reaches 4, you have to again decrease it. 3, 2, 1, 0. After 0 again increase 1, 2, 3. Then once it reaches 4, keep on decreasing 3, 2, 1, 0. So again potassium and calcium have 1 and 2 valency. So this is how you remember the valency of first 20 elements. Last concept in this is, there are some elements which show more than one valency, and we call that as variable valency. Now, in this case, what is the reason for variable valency? The reason is sometimes atoms lose electrons from penultimate shell too. What is penultimate shell? Say, let me take an example of copper. So copper has the orbit structure of this. Okay, so we know the outermost shell is known as valence shell or outermost shell, and you can call it as ultimate shell. So penultimate means last but one, means the next here. So this is called as penultimate shell. So usually we know electrons are lost by valence shells. So you can observe this electron. So when copper loses this electron, it is losing one electron, so it will form copper plus 1 ion. But sometimes what happens, it can also lose the electron from the penultimate shell. Observe this electron. Yeah, So it has lost 1 and 2 now. So in this case, it will form copper plus 2 ion. So here the valency of copper can be plus 1 or can be plus 2, depending upon how many electrons it is losing. So if it is copper plus 1 ion, you can call it as cuprous ion also. Copper plus 2 ion, you can call it as cupric ion. So this is the reason why some atoms show variable valency. Some more examples we'll see. If an element exhibits two valencies, especially only for metals we are talking here, so we use suffix OUS for lower valency and use suffix IC for higher valency. For example, you take iron, it has valency 2 and 3. So 2 is lower valency and 3 is higher valency. What is the Latin name of iron? Ferrum. So use that word. So ferrous and ferric. Similarly, tin has variable valency 2 and 4. Its Latin name is stannum. So you call it as stannous or stannic. But nowadays, IUPAC has given different names, like you will use the English name only and you will represent the valency in bracket with Roman number. So for example, ferrous you are representing as iron 2, ferric as iron 3, stannous as tin 2, stannic as tin 4. For example, you take FeO, it is ferrous oxide or iron 2 oxide. Fe3O4, ferric oxide or iron 3 oxide. SnCl2, stannous chloride or tin 2 chloride. SnCl4, stannic chloride or tin 4 chloride. So these are IUPAC names, these are common names. Okay, there are some non-metals which can also show variable valency. For example, nitrogen and phosphorus show 3 and 5, two different valencies. Sulfur shows three different valencies, 2, 4 and 6. So this is all about variable valency, and I hope you understood this concept very well. We will meet in the next session. Until then, take care. Bye bye.